everyone. Welcome to Tech Simplified channel. Today we will understand the Hill Cipher, one of the classical ciphers in cryptography. We will see what it is, how encryption and decryption work, and walk through the simple example. So let's first understand what is Hill cipher. So the Hill cipher is a polygraphic substitution cipher, which means it encrypts block of letters at once, not just single letters. It is invented by Lester S. Hill in 1929. The interesting part is that it uses the linear algebra, specifically matrix multiplication, to perform encryption and decryption. So let's understand how the encryption process done in the Hill cipher. So first we convert letters to numbers. A is 0, B is 1, all the way Z equals to 25. Then we group the plain text into block, the same size as the key matrix. Each block is multiplied by the key matrix, and after that we take the result modulo 26 to stay within the limit of A to Z. Finally, we convert the numbers back to letters, and that gives us the cipher text. Now, for the decryption process, the steps are almost the same, except we need to inverse the key matrix modulo 26. So, we can compute the modular inverse of the matrix, multiply each ciphertext block by this inverse, take modulo 26 and then convert the numbers back to the letters. That recovers the original plain text. Okay. Now, for as example, our matrix is, for example, 3, 3 and 2, 5. This is a 2 by 2 matrix, and our plain text is a hello. Uh, uh, when we apply the Hill cipher steps, it convert into a ciphertext. Now, when we decrypt, we get a hello X. Notice the extra X at the end. That's just padding added to make the next fit into block of the two letters. Okay. Now, what are the key points we can remember about the Hill cipher? The first is the key matrix must be invertible modulo 26, otherwise decryption is not possible. And padding usually with the letter X is added when needed. And Hill cipher is often demonstrated with the 2 by 2 and 3 by 3 matrices. And it is a great example of how mathematics, especially linear algebra, is used in the cryptography. So let's develop a Python program to implement the Hill cipher. For implementation of the Hill cipher, we have to first import the NumPy library. The NumPy provide functions for the numerical and the matrix operations. Now we have to make a one function that converts a strings of letters into numbers, and each letter is mapped to a number. For example, A equal to 0, B equal to 1, and so on, Z equal to 25. So this is required because encryption and decryption involve arithmetic operations on numbers, not characters. Okay, and it returns the text dot upper that converts everything to a uppercase to avoid case mismatch. And if char dot is alpha, ensures only alphabetic characters are included in ignoring the spaces and the punctuations. Okay. Now, similarly, we have to make another function that convert numbers to text. Here, num percentage 26 ensures number always remains within the range of 0 to 25, and adding ORD a shift value back to ASCII code of the capital letters. Okay. Now we are making an encryption function. It accepts the plain text message and a square key matrix. Okay. So in this method, we have to first find the size of the key matrix for 2 by 2 matrix n equal to 2, and this value determines how many characters are encrypted at a time. Now converts the plain text string to a list of numeric values for the mathematical operations. Okay. If the plain text length is not divisible by n, for example, there are 5 letters in a 2 by 2 key, so we required a padding. So pad the plain text with x, that value is 23. X is traditionally used as a filler to make the message fit the block size. Okay. Now we have to check an empty list to store encrypted numeric value. Okay, we process the plain text in chunks of size n. Each chunk is a vector that will be multiplied by the key of the matrix. Extracts a block that is a 2 by 2 key and convert it to a numpy array of the matrix operations. Matrix multiplication is also done, then apply mod 26 to ensure the results map back to A to Z. Okay, and thus the resulting encrypted numbers into the ciphertext list. Okay, so in this way we can implement the Hill cipher encryption method, and it returns the number to text ciphertext value. Okay, now we have to make one method that convert the final ciphertext numbers back to the letters. Okay, and this function converts the final ciphertext numbers back to the letter. This function decrypts the ciphertext and it requires computing the modular inverse of the key matrix. Okay, so for that also we have to first check the length of the key matrix. Okay, and then converts the ciphertext letters to a numeric value. Okay, calculates determinants of the key matrix. The determinant must be co-prime with 26 for the key to be invertible. Okay, and then computes the modular inverse of the determinant modulo 26. If this fails, the key is invalid for the Hill cipher. Okay. Now the key. Now we have to calculate the key matrix inverse. In that, np dot linalg dot inverse key matrix gives the floating point inverse multiplied by determinant and round to form adequate matrix multiplied by determinant inverse modulo 26 and take everything mod 26 to keep values from 0 to 25. Now initialize list to store the decrypted numeric value. Loop over the ciphertext in block of size n. Take each ciphertext block for decryption. Multiply each ciphertext block with the inverse key matrix and take modulo 26. This yields the original plain text number. Okay. Now append decrypted numbers to plain text list. And after that, we have to convert decrypted number back to letter to construct the plain text. Okay. So in this way, we can make a decryption method. Now we have to take a plain text from the user and define the key. The key must be invertible mod 26. So this is commonly used 2 by 2 example. Okay. Now we have to take input from the user, that is a plain text from the user, And after that, we have to encrypt the plain text using the Hill Cipher encryption. And after encryption, we have to decrypt the cipher text back to plain text using the modular inverse key matrix. Okay. Now we have to print the original plain text, the encrypted cipher text, and the decrypted plain text. It should match the original message, but there is a possibility that extra X padding at the end. So that is in the case when your plain text size is not modulo 26. Okay. So in this way, we can implement the Hill Cipher algorithm in Python. Okay, so now I start run this code. So after running this code, it prompts me to enter the plain text. So for example, I write Shanti. So it convert into a cipher text, and after decryption, it also give me the plain text. Okay, but let me show you the case of the padding. So if I run this code, and enter for example hello. So hello has the 5 letters, so the modulo 26 is not possible. So in this case you can see after decryption there is a one extra x is added as a padding value. So in this way we can implement the Hill cipher in Python. So if you like this video, please like and subscribe and comment for any query. Thank you.